Okay, I want to talk about how to do a confidence interval here for proportions. Now in 213, you may have seen either this p tilde version, okay, this is called the Wilson statistic, or your teacher may have taught you here the p hat, which is called the Wald statistic. Okay, so here in 217, I'm going to tell you when it's appropriate to use either of these two. Okay, so here we have a little bit of a typo in the notes. It says here if n times p hat or n times q hat are less than 5, then we should be using here the Wilson confidence interval formula. That is p tilde plus or minus your alpha value all over p tilde multiplied by p tilde 1 minus p tilde, and that's over top of n plus 4, and this is square root. Okay, so this is what you want to be using if np is less than 5 or if nq is less than 5. Okay, that's what you want to be using if that's true. However, if n times p hat is greater than 5 and n times q hat is greater than 5, then you can be using the Wald, okay, which is p hat plus or minus z alpha over 2 p hat times 1 minus p hat over top of n for your confidence interval. Okay, so that's how to tell when to use which if you're using the Wald or the Wilson statistic. Okay, let's see an example of what we should do here. Okay, so it says here, suppose a study of 45, okay, so that's the sample size, 45 businessmen found out that 3 went out of business last year, okay? So this is the number of businesses that went out of business. This is the number of successes, okay? Produce a 95% confidence interval for the true proportion. Okay, so the first thing you should do is this assumption check. Okay, we want to know whether or not we're using the Wilson or the Wald. Okay, so we go n multiplied by p hat. Okay, so n here is 45. And then, of course, p hat is just going to be the number of successes, which is 3 over 45. Okay, so we're multiplying this together. These 45s will cancel, and we get this value to be 3. Okay, so this is obviously smaller than 5. Okay, so because this value is smaller than 5, we can also check n times q hat. Okay, this would be 45 times by 42 out of 45, giving us the value 42. Okay, sorry, that's a 42. Okay, which is obviously greater than 5. Okay, so this one's okay, but here this isn't good. Okay, so because 3 is less than 5, what this is saying is we should use the Wilson. Okay, we should use this p tilde, which is also called the plus 4. Okay, so this is calculated by having the number of successes plus 2 over top of the number of samples plus 4. Okay, we should use the Wilson statistic instead. Okay, so how we do this is, remember our formula for the confidence interval then will be p tilde plus or minus our test statistic, multiply a p tilde by a 1 minus p tilde over top of n plus 4, and we take the square root of that. Okay, this is easy enough to do. First, you might want to calculate p tilde. Okay, p tilde will just be the number of successes divided by the number of trials, but on the top we're going to add 2, on the bottom we're going to add 4. This gets us 5 out of 49. Okay, so 5 out of 49 for our p tilde. Then we can just fill in the rest of this formula. This is 5 out of 49. What was our z value that we wanted to calculate? You might want to draw yourself a little picture here. Remember here we wanted to be 95% confident. meaning that we've got 5% in each tail. And in a Z, we know that the values here are 1.96 and negative 1.96. Okay, you can verify that, of course, by looking at your table. Which will look like this. Okay, so we now have our Z value, which is 1.96, and then we're going to multiply here our P tilde and 1 minus our P tilde. And this will be divided by n plus 4, which is 49. Okay, giving us our two limits, 0.017, this is the lower limit, and the upper limit here of 0.187, if you round. Okay, so that's the upper limit. Okay, so here's the confidence interval for the Wilson. All right, you could also do this with Minitab. Okay, let me show you how to do that with Minitab. Okay, so for Minitab, we would go to Stat, Basic Statistics. Here this is a 1 proportion. In this case, we're using the Wilson, so we want to make sure that the number of events, these are the number of successes here. This is the number of successes plus 2 because you're using the Wilson in this case. That is number of events being 5, that's 3 plus 2, and the number of trials is the number of samples plus 4. Okay, so that's 45 plus 4, which would be 49. Under our options, we want to make sure our confidence level here is 95%. For confidence intervals, the alternative is always not equal, and we want to also check off that this is based on the normal distribution. And here you can get the same confidence interval that I calculated by hand. Notice though, if you didn't realize that the Wilson needed to be used and you didn't use P tilde, instead you used P hat, which is just 3 out of 45. Okay, if you were to do this by Minitab, that would be basic statistics, 1 proportion. Here you would not use a plus 2 and a plus 4. You would just use n, which is 3, and 45, sorry, x, which is 3, and n, which is 45. Here, making sure that your options are all the way you want it to be. And here you would get your confidence interval to be a little bit different. Okay, so here your confidence interval would be 0 to about 0.14. Notice how that there's kind of a difference here. Okay, so remember, you should be using the Wilson statistic if n times p is less than 5, or if n times q is less than 5.